Guys, someone stole the coffee machine.
All right, Kripa and Megan. I'm gonna give you this case, but don't let me down.
Don't worry, we won't.
Let's start with an interrogation of the suspects.
Okay, bring them in.
Bring who in? We don't have anyone yet.
Fine, we'll just grab someone. Hey, you! Grab him too!
I got it.
Why am I here? I have papers to grade.
I know you did it.
Are you crazy? I'm the one that wanted coffee in the first place. Why would I steal it?
I know one of you stole the machine.
Why would I steal it? It's my machine!
Maybe his point.
No, he's going on a tangent.
I assigned you this case. Why would I steal it?
We know you did it!
Also, who was playing this dramatic music? Oh. This is dumb. I'm leaving.
There's a shadow. I wonder how fast the tip of the shadow is moving.
Amira, 5 feet tall, is walking away from a light source that is 6 feet off the ground. She is walking at 3 feet per second. How fast is the tip of the shadow moving? First, let's draw a diagram. We know that Mira is walking at 3 feet per second, so that makes dy dt equal to 3. The tip of the shadow can be represented by x plus y, and in order to find how fast it is moving, we're going to need to find dx dt. In order to do so, we need to set up a proportion of similar triangles and then solve for the relationship between x and y. Now, let's differentiate this equation to find dx dt. Now that we know both dx dt and dy dt, we can differentiate the equation of the length of the tip and then plug in what we have solved for to find out our answer, which is 18 feet per second.
How does that have to do with the case, though?
You're right. Let's just look for clues to figure out who actually stole the Keurig.
A mug is represented by the curve c equals 1/2 x sine x plus 1/2. If the curve is bounded by x equals negative pi thirds and x equals pi over 2, find the volume of the solid revolved about the x-axis. If your answer is less than 15, remember the letter R. If your answer is more than 15, remember the letter A. Since there is no negative space between the curve C and the x-axis, we can utilize the disk method to find the volume of the solid. The formula for disk method is pi times the integral from the lower and upper bounds of whatever region you want to rotate of the radius squared. The radius in our case is the distance from C to the x-axis. Next, we plug in the formula for the curve C in the equation and put the correct bounds as given by the problem. Plug it into the calculator and there's your answer.
We got 5.132, which is less than 15, so we gotta make sure to remember the letter R.
Wait, there's something on the back of the sheet.
Maybe it's another clue.
The temperature of a room is 70 degrees Fahrenheit when coffee is brewed at 7:05 a.m. Its initial temperature is 195 degrees Fahrenheit. At 8:05, the coffee has a temperature of 95 degrees Fahrenheit. When will the coffee be too cold to drink? So we know this is a Newton's law of cooling problem. First, let's define our variables just so we can keep track of them throughout the problem. Newton's law of cooling tells us that the rate of change of the temperature of an object is proportional to the difference between its own temperature and the temperature of its surroundings. This is a separable differential equation, and this is how we need to separate them to be able to integrate them. We know that T sub r is a constant, so in our next step, we'll plug in 70 degrees for that. Integrate both sides, keeping in mind that K is just a constant of proportionality, not a variable. Don't forget your plus C. Let's manipulate this question to isolate T sub C on one side. Let's use the two temperatures of the coffee that we know to solve for both K and C. Now that we know both K and C, let's rewrite our equation with the values substituted. Plug in 80 for T sub C to solve for the time at which the coffee will reach that temperature. Isolate the variable for time. After taking 1.569 hours, turn this into an actual time, and we get 8:39 a.m.
Well, based on the problem, it says to remember the letter S.
Y'all better find this coffee maker by any means necessary.
Are you kidding me?
Wait, say it again.
Are you kidding me?
No, she means beans.
I think the final clue is with the coffee supplies. Let's go check the cabinet. Coffee pours into a mug at a rate given by the function represented by the following Taylor series. If this function represents the constant rate at which coffee is pouring into a mug in cubic inches per second, find the rate at which the height is changing of the mug, given that the mug is a cylinder and the radius is constant, with r equaling 2 inches. First, we need to identify which function the Taylor series is representing in order to find the constant rate at which the coffee is pouring. The series looks like e to the x, but instead of x there's a 2, so therefore the series represents e squared. Now we know that dv dt, where v is the volume of the mug, can be represented by e squared, and we know our radius is 2 because that was given. The equation for volume is pi r squared h, but we can plug in 2 for the radius and simplify a bit. Differentiate both sides. Plug in e squared for dv dt and then isolate dh dt to find the answer, which is 0.588 inches per second.
Megan, I think it's the final clue.
I think you're right.
This is stupid.
Hey, what are you doing? Let's try and solve this actually. It might give us the last clue.
No! We'll never solve the problem now! Why? Ritika, why?
Are you kidding me?
To find the sum, we have to first identify what kind of series this is. By looking at it, we can tell it's a convergent geometric series, so the sum can be given by a over 1 minus r. A is 9/8 in this case, because after plugging in the first nth value, that's what we get as the first term. R is 7 over 16. Simplify this and you get 2.
So the back of the clue says to remember the letter D. So our 3 letters are R, S, and D. Wait, aren't those Ritika's initials?
Oh my god, Ritika! You stole my coffee!
Ah!
Hey Megan, make me some.
I hate coffee.
Wait, time out. Did y'all hear that?
How does it have anything to do with